Hi, in this video, I'm going to cover the two examples of the hypothesis for the mean. So the first example is the following. Here, uh, the first situation is that we know the sigma. So that is a little bit weird because we don't have the population data, but somehow the sigma is known. Then in that case, we can use a normal distribution. So take a look at this example. So this is a situation that we know the sigma. So a company manufactures the bicycles, receive the steel rods in large shipments from supplier. From the past experience, the bicycle company manager knows that sigma is a 0.2. And then the here's a typo. Lengths are approximately normally distributed. So let's denote the x. X is the length of the rows. And then the manager takes a random sample of the 36 rows. So that means that n equals 36. And then the sample mean x bar is a 12.09. Then the company needs a rod with a length of the 12 inches in order to assemble the bikes properly. So because too large and the too small rods are unsuitable, shipments not meeting the requirements and sent back to the supplier. Help this manager determine whether the shipment should be accepted or rejected. Okay, so the first step is that we need to set up the null hypothesis and alternative hypothesis, right? So that's a step one. We set up the null hypothesis and alternative hypothesis. So the null hypothesis mean has to be 12. So mu equals 12, right? And then the alternative hypothesis, mu is not equal to 12. So how do I know whether it's an alternative hypothesis, mu is greater than or less than or is not equal to? Well, it says if it is too large or too small, that makes a problem. So that's why the alternative hypothesis has to be not equal to 12, right? Inches. So then the second step, we need to check the condition. So in this case, the sigma is known. And then the sample size is large enough. And also the x follows normal distribution, right? So sample size in this case, 36, which is a greater than 30. Then we can say that the x bar follows normal distribution by central limit theorem, okay? So then we can use a z-test statistic. So as a third step, we can calculate the z-test statistic, which is the following: x bar minus population mean mu over standard error, and the standard error is a sigma over square root n. So what you need to do is that you plug in the numbers and you calculate this test statistic. Then take a look. So the sample mean is a 12.09, and the population mean, which comes from the null hypothesis, so which is 12, and divided by standard error. So sigma is known as a 0.2, and then the sample size is square root 36, right? So n equals 36. That's why here is a square root 36. Then let me calculate with the Excel. So here, numerator is just 0.09 because 12.09 minus 12 is a 0.09. And then the denominator is, with the equality, 0.2 over square root 36. So actually the square root 36 is 6, right? So the numerator over denominator, then we can find the test statistics. So 0.09 over this number. Then we have a test statistic, which is 2.7. Okay. So I covered this one in the previous video, which is about the hypothesis test for the mean, but let me do it again here. So there are two ways to make a decision whether you reject an hypothesis or you fail to reject an hypothesis. So let me show you both of them. The first one is the following. You compare this z-test statistic, compare with the critical value, okay? And it would be better to compare the absolute value because I don't want to care about the sign. So in the case, you better take the absolute and compare it. And as long as your test statistic is greater than critical value in absolute, then you reject the hypothesis, okay? So that means that if the test statistic is smaller than the critical value, then you fail to reject the hypothesis. That being said, that you don't have the enough evidence, you don't have the strong evidence to reject the hypothesis. Okay? And the other way is that you are using the p-value and the alpha level, significance level. So the p-value comes from the test statistic. So when the p-value is smaller than the alpha level, then we reject the hypothesis. On the other hand, the p-value is greater than alpha level, then we fail to reject the null hypothesis. So I'm gonna show you both of them. The first one is, let me calculate the critical value from the alpha level. So start with the z distribution, the standard normal distribution. Mean equals 0, standard deviation equals 1. And our test statistic is located here, 2.7. But then here, the significance level, we are using the 5%, right? The alpha level is 5%. Then we can find the critical value as following. This is a symmetric in here. Alpha level is a 5%. That means that this shaded area is a 90%. Sorry, the 95%. And here, this purple one is each of them 2.5% each, right? So under the distribution is 100%. So 100 minus 95%, we got the 5%. 5% divided by 2 is a 2.5%. So then this number is a critical value. You can find the -1 and the +1. Let me find the -1. So in order to find the -1, put the equality, norm inverse, 0.025, that's 2.5%. Mean equals 0, standard deviation equals 1. Then I got -1.960 up to 3 decimal places. Just in case, let me find the positive one. So in order to find the positive one, you do the same thing, norm inverse, but then you need to put the 0.975, so 97.5%. Why is that? 2.5%, 95% together is a 97.5%. If you put the 0.975, mean equals 0, standard deviation equals to 1, then it gives you this number. So mean equals 0, standard deviation equals 1 as you expected. It's the same as the -1, but it's a positive, so 1.96. But what do you see here? Well, our test statistic, z test statistic, is a 2.7. But then the critical value is a -1.96 or the 1.96. That's why I'm telling you it's better to use the absolute value. So we don't want to take consider the positive or negative. So always it's better to use a positive one. But it turns out test statistic 2.7 is greater than 1.96, the critical value. So that means that we do have a strong evidence to reject the hypothesis. In the case, this manager, he has to reject this image, right? Now, let me use the p-value and the alpha level. So let me copy and paste this graph. So this was the first way. Well, let me use a second way to compare the alpha level with the p-value. So here, once you have the test statistic, this shaded area, and here -2.7 and this shaded area together, that gives the p-value. When you assume that null hypothesis is true, what's the probability you get the test statistic 2.7 or higher, or the -2.7 or lower? That is the p-value. But why do we consider the both sides, left one and the right one? Because the alternative hypothesis is two-sided, not equal to. In that case, you calculate the one shaded area and then multiply by 2. So I'm gonna find this one. I'm gonna find this shaded area and then multiply by 2. In order to find this shaded area using the norm dist, so put the equality, norm dist, -2.7, mean equals 0, standard deviation equals 1, and cumulative from the -infinity to the -2.7. Then it turns out the 0.003, but like I told you, we need to sum of this one and that one, right? So we just found the one-sided. That means that you just need to multiply by 2. So this one times, give me 1 second. Yeah, put the equality, and this one times 2. Then we got the p-value, which is a 0.0069. So the left one itself is a 0.00346 something. But 0.00346 times the 2, we got around the 0.0069. Okay, so that means that our p-value is a 0.0069, but the alpha level in the question given as a 5%, that is a 0.05. Which one is smaller? The p-value is smaller. That means we do have a strong evidence to reject the hypothesis. So it is consistent. As you noticed, When you compare the critical value and the test statistic, basically you're using the z-score here, x values. But when you're using the p-value and the alpha level, you are using the percentage, this shaded area, okay? So they are consistent. But the important thing is that when you calculate the p-value, you need to be very careful whether the alternative hypothesis is not equal to or greater than or less than. So if it is not equal to, then you need to consider the both sides, the left one and right one. So that's why you have to multiply by 2, find the p-value. Otherwise, you make a mistake, okay? So that's a one question that's a little bit weird because like I told you, in general, we don't know the population standard deviation, but this question lets you know the population standard deviation and the sample size is large enough and the data X itself follows normal distribution. That's why we can use a normal distribution, but that's not realistic. So let's take a look at another example. Here, a marketing researcher wants to estimate the mean amount spent per year on a website by membership members, shoppers. Suppose a random sample of 100 membership shoppers. So that is n equals 100. So we have the sample size n equals 100 who recently made a purchase on the website yield the mean amount spent of $56. So that means the X bar is $36. And then the standard deviation, that is a sample standard deviation, which is 49. And then the question is following. Is there evidence that the population mean amount spent per year on the website by membership shoppers is different from $50? So that means they are saying that the population mean is a 50. Okay, so the first step, as usual, null hypothesis, you set up the null hypothesis and alternative hypothesis. So the null hypothesis mu equals 50, and the alternative hypothesis mu is not equal to 50. Oh, by the way, here I made a mistake. The sample mean is not 36, it's 56, right? And then how do I know that the alternative hypothesis is not equal to? Well, from the question here is different from the 50. So that's why the alternative hypothesis is not equal to. That means that this is a two-sided test, right? And then the second step, we check the condition. Oh, this question, we don't know the sigma. So sigma is unknown, right? But at least we have the pretty large sample, so n equals 100. In that case, instead of using the normal distribution, we need to use a t-distribution, okay? Because that sigma is unknown, that means that we cannot use the normal distribution anymore. Sigma is known as a strong assumption, right? So in general, we use a t-distribution for the mean, okay? And then as a third step, we calculate the t-test statistic, which is the following: X bar minus population mean over the standard error. But the standard error, now we are using the sample standard deviation, right? Because we don't know the population standard deviation sigma. That's why we replace the population standard deviation with the sample standard deviation S. To remind you, the previous question, the z-test statistic is X bar minus population mean over sigma over square n. So they look pretty much same except for the sigma and here, right? As sample standard deviation S. So then the next step is that you need to plug in the numbers. So here the X bar is a 56 and the population mean again comes from the null hypothesis. So I need to plug in the 50 and divided by the sample standard deviation, which is a 49 over the square root of the 100. So because the sample size is 100. So that is basically 10. Now let me calculate this one by using the Excel. So the numerator is a 6. Numerator is, give me a second, I need a space. So numerator is a 6 and denominator is a 49 over 10. That's a complex fraction. So you can think that this is a 60 over 49. So let me calculate the 60 over 49. So if you are not familiar with the complex fraction, so Google it and take a look at a couple of examples. Okay. So it turns out that our test statistic is a 1.408 up to 3 decimal places. Now, same as the previous question, you can either compare the test statistic with the alpha test statistic with the critical value, or you calculate the p-value and then you compare with the alpha level. Now, in this question, let me calculate the p-value and compare with the alpha level. So here, this question, I have a t-distribution. This is a t-distribution, and here is a 0. And then our test statistic is located here, 1.408. But since the test is a two-sided test, I need to calculate this one and then multiply by 2, then I can get this p-value. Okay, so let me show you the step-by-step. So what I'm going to do is, as usual, the Excel is calculating from the left to the right. So when I put the t dot distribution, and then 1.408, and then the degrees freedom is a sample size -1. In this case, 100 minus 1 is a 99. And then true means that from the negative infinity to the 1.408. So then we can find this shaded area that turns out the 0.9188 something, right? But what we want to find is blue shaded area. That's why we need to use the complements. 1 minus that one gives me this one-sided, this shaded area. Okay, that is a 0.08 something. And then you multiply by 2, then we got the p-value, which turns out 0.1622, right? So this shaded area is a 0.0811 something. And then when you multiply by 2, that you have the p-value, which is a 0.1622. Now, you compare with the alpha level. So here, the alpha level is given as a 5% because it says use a 5% level of the significance. So alpha level, 5%, 0.05. Then it turns out your p-value is higher than the 0.05. That means you do not have a strong evidence to reject null hypothesis. Okay. All right, so that's it. So this question is a kind of realistic question because we don't know the sigma. Instead, we calculate the sample standard deviation, which is a 49, but sample size is large enough, so we can use a t-distribution. And then the steps are pretty much same as a previous question. You calculate the t-test statistic and then calculate the p-value, and the p-value turns out pretty large, 0.1622. So that's why, which is greater than the alpha level. So we fail to reject the null hypothesis. So our decision is a fail to reject the null hypothesis. We don't have the strong evidence to say that mu is not equal to 50. Okay? Again, the intuition is when the sample mean and the population mean are pretty different, then we're gonna have the very large or the very small test statistic. In this case, let's say the X bar is like a 70 something, 80 something. Then probably we have a large test statistic, given that the denominator, the standard errors are pretty much same, right? So if the numerator, the gap is large, then you will have a very large or the very small test statistic. Then the p-value is very, very small. So if you have a small p-value, that means that you have a really strong evidence to reject the null hypothesis. But in this case, because the sample mean and the population mean is not that different, that's why our test statistic is not that large. That's why the p-value is greater than 10%. So even though we are using the alpha level 10%, our p-value is still greater than 10%, then we fail to reject the null hypothesis. That's it.